Hey everyone, and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss part 1 of seminar 7 of the University of Debrecen in the Biostatistics subject. If you remember, we have just said in the previous videos that the Z, which we can get from the standard normal distribution tables, okay, we can use it also here. So we said last time that we can convert x, okay, x of x any variable in a sample, because if we have a sample which has a mean, for example 100, okay, and it has a standard deviation, for example, of equals, let me write it this side, standard deviation, what is not right? Okay, the standard deviation of, for example, 5 or 6 or 7, whatever. So I have a standard deviation and I have mean. This means it is not a standard distribution, because the standard normal distribution has a mean of mu equals 0, the mean equals 0, and the standard deviation equals 1. So in order to convert x into z, we said that z equals x minus mu divided sigma, right? So then we said in some cases we have the sigma of the means, okay? Sigma of the means. So we said instead of having sigma, it will be x minus mu divided sigma of the sample divided the square root of n, okay? It's called the sigma of the population, okay? Divided n of the sample, okay? So this we said this is in case of the means, okay? We have distribution of means, so this will be the formula, which is this one. So if we are talking about the means, we cannot use the formula z equals x minus mu divided sigma, standard deviation. We cannot use this one if we are talking about the means. If we are talking about the means, we have to use the formula z equals x minus mu divided, we called before SEM. You remember? What you called standard error of the mean. Standard error of mean. Okay, SEM. So we can say that we said that we can use SEM instead of sigma, and SEM equals sigma divided the square root of n. Sigma of the population and n of the sample, okay? So if we are talking about the mean, okay, we can still say that SEM equals sigma divided square root of n and n for the sample, okay? But here actually there are some conditions that n must be a big value, like more than 30. It should be a big value, it should not be a small one, okay? And this sigma will be the sigma of the population which we have, and if we don't have, we can use S for the sample as well. If n is big, we can use S of the sample, so we can replace it with S as well, okay? But let us, for time being, focus on the sigma as it is, okay? Okay, so it will be, SEM will be sigma divided, so our Z will be equals x minus mu divided SEM, or x minus mu divided sigma divided the square root of n, okay, in the denominator, okay? But because we are talking about the mean, x here is one of the x bar, one of the means, because this is the distribution of the mean. You remember we said that our distribution will have a big population, we'll have one sample which has some elements here, okay, just let me draw them here. So we'll have another sample which is having this item, another sample which is having these items. So I have 3 samples, for example, each one of them has x bar, x bar, x bar. We can call x1 bar, x2 bar, x3 bar. So if we have this x1 bar, x2 bar, x3 bar, so we can get the mean of the means, okay? That's why we are going to use, in this case, we are going to use this formula. It's called the distribution of the mean. So we'll treat the means, okay, as the individual case which we have before. So we can call this one z equal x bar minus mu divided in the denominator. We can put between brackets sigma divided by square root of n. Okay, I hope this one is clear. If we don't have sigma even, we can use the sigma for the sample s. If the sample is big number like 20, 30, 40, 100, we can use this s instead of sigma. So the way or methodology here of using z-test, okay, if I know the standard deviation sigma, so the z-test of statistics, it has 6 steps, okay? The 6 steps, the first step here that we have to choose the significance level. Significance level, this is what we are sometimes call it rejection level. So, for example, if I want to stay my data is here within this range, okay? Okay, if I say my significance level alpha equals 0.05, for example, just as an example, okay? This means that if this is my rejection level, so if the data fall here, so I'm going to reject the data. So this is my acceptance level, okay? And this is my rejection level of the null hypothesis, okay? So this is called alpha. In other words, I'm just setting a limit. If you cross this limit, it will be rejected, okay? If my z cross this limit, it will be rejected. If it is within the other side or before crossing this limit, it will be acceptable to me. This is the point of this significance level. So just I'm setting this level, okay? If my data or my z cross this limit, it will be rejected. If it did not cross it, it will be accepted. And by the examples, it will be more clearer, okay? So this is what we call the significance level. So I have to set it in advance. On this distribution graph here, let me erase this one. So I can set it, for example, 5% here to the right or 5% to the left or 10%. If it's not given, I can assume it as small as 0.05%. Which is reasonable, okay? I can assume alpha, but if it's given, I have to use the one which is given. The example could be 0.1, could be more or less, okay? And we'll come touch it with the examples which I'll give before we start the examples in the seminar, okay? So choose the significance level. So it's like a boundary. If we cross this boundary, if our z cross the boundary, it will be rejected for the null hypothesis, okay? Or it will be accepted for the alternative hypothesis. And we'll come to this in detail. Then we have to state the null and the alternative hypothesis. Null hypothesis, which is H naught, H0. This is null, 0, okay? And it's alternative, okay? So this will be my base. For example, this will be my base hypothesis, okay? Which is going to be rejected if the data fall, for example, in this area. So if Z falls here, so I'm going to reject the null hypothesis and I'm going to accept the alternative hypothesis. It depends on my way I'm working out the null hypothesis and the alternative hypothesis, which we'll come to know in detail in the incoming examples, okay? So based on the significance level which we have here, if I set the significance level, for example, okay, 5% from here, so my data will be, I'll have to go to Z standard distribution table, okay, and find the value, which will be, I can get Z from the table will be 1.645, okay? So 1.645, this will be my Z, okay? Based on the significance level. So once I set the significance level, automatically I can go to Z tables or the standard distribution table and I can get the Z from the graph, okay? I can get that from the graph, which called Z critical, okay? Z critical from the graph, okay? Based on the alpha. So I use alpha to get the Z critical, okay? And then I have another Z which will be calculated here, okay? So the third point that calculate the Z test statistics. From this formula, I have to calculate the Z. Based on the Z which I got from the calculated one and the Z which I got from the graph, I have to compare them and then I can decide. Find the critical value of Z in the standard normal table, okay, Z critical, which is this one, based on the alpha, and compare Z calculated with Z critical, and decide whether it support or it reject my null hypothesis, okay? Then I write the conclusion of it. I think after taking one or two examples, which are very quick ones, before we start our similar examples, it will be very clear to us. So here, once we get the problem, we'll have H naught, which is the null hypothesis, okay? The null hypothesis will be depending on the problem. So I can assume that the mu, okay, which have equals the mu naught, okay, which is given in the problem. If I assume that mu is equals to the mu naught, which is given in the problem, so this will be my base case. This will be my null hypothesis, okay? H naught, the base case, the null hypothesis. So I'm agreeing or following up what given in the problem, okay, in the question. So the null hypothesis, I assume that mu equals to mu naught, okay? The H alternative or the alternative hypothesis could be that the mu is greater than mu naught, okay? For example, he said in the problem that H naught is mu less than, for example, okay? Let us erase this one, okay? If I say that H naught is less than mu naught, okay? This is my null hypothesis, okay? Null hypothesis, okay? H naught is less than. So my alternative will be that the mu is greater than mu naught. Then I'll prove which one of them is right, okay? Or the other way, it could be in the problem itself that H naught is greater than mu, so my hypothesis would be H alternative, mu is less than, it should be the opposite, okay? Or it could be H naught equals to mu. So in this case, my H alternative, the alternative hypothesis would be that H alternative, it is not equal, mu not equal. It is not greater, not less, but it is not equal. Okay, so it depends on H naught, the null hypothesis, we can decide what is the alternative hypothesis. So taking this example, in this example, I assume that alpha, okay, the confidence level is 0.05, okay? And I assume that H naught is less than mu naught. As per my problem, H naught is less than mu naught, okay? Then H alternative will be that the mu is greater than, okay, sorry, here, my null hypothesis will be that mu is less than mu naught, okay? Mu is less than mu naught. So my alternative hypothesis will be the mu, the opposite, will be greater than mu naught, okay? So the first thing, I assume that the null hypothesis would be something and the alternative will be the other way around, and to prove which one of them is right. So the first thing, for example, I assume here that mu naught less than mu naught, okay? So this will be my H naught, the null hypothesis, okay? So H alternative should be something else, okay? It should not be equal to it. So it should be mu, instead of less than, it should be mu greater than mu naught. So I assume this one, the null hypothesis, then I work on the alternative. If the alternative happened, this means that the null was wrong, okay? I try to approve this one. So here, the alternative that mu is greater than mu naught, okay? So let us assume that the alpha is 0.05 as given here in the example. So from this alpha, 0.05, I'll draw the distribution graph. And here, this will be 0.05%, okay? 0.05 means 5%, okay? So it will be the last 5% here. This is, okay, so this is 50%, and here's 50%, okay? So I assume that you are familiar with the tables, the tables for the standard distribution. we have two types of tables. One of the table which is to the right, which will find the table like this, and this means that it is giving the data to the right, and we have another distribution table that giving the data to the left. Okay, so you have to be careful which table you are using. If you use the wrong one, you will get the wrong data from the Z table. Okay. Okay, so let us do this one. So here I'm going to use the table to the right, okay, which has tail to the right, okay, the normal distribution table. So if I went there and I check alpha, okay, for 0.05, what is this 0.5? Here this is 50%. 50% is the probability. The total probability under the standard distribution is 100%, is 1, okay, is 1. Total probability is 1, the total area. So the area here is the probability. It is not the Z value. It's not the Z value. So when I go to the the Z table, the standard distribution table, I should not look for the column value here. I should look at the data which inside the table. Which one gives me 0.05? So, but in the same time, I have to make sure which table I'm using. So here I have alpha, which is 0.05, okay, to the right, okay, because I assume that the alternative mu is greater than mu naught. So if I assume that mu naught anywhere here or whatever, so it will be in the right side, greater than it. Greater means to the right, okay? That's why I put my alpha in the right. If it is less than, I have to put alpha in this side. So I have to check my alternative to the right or to the left. So in this case, my alternative proposes that mu is greater than mu naught. So if I assume mu naught is here, so mu will be greater to the right. So I put alpha to the right. If it happens and it came within this area, so the alternative will be right, and the null hypothesis will be wrong. Okay, it will be rejected. So I'll go to the standard normal distribution table and see which probability. Here, this is the probability. The area is the probability. Which probability is 0.05 correspond to which Z? Okay, I know that it will be 1.645, but just I'll show you how to get it. So one point which we have to be careful to pay more attention of, that okay, as I told you here, this is the mean. So I have here 50%, the probability here 50%. Okay, and here 50%. So I have already deducted from here 5% here. So I have only here 45% for this area. Let's make it in different color, red color. So this is 45%, and this one is 50% already. 50%. The full left side will be 50%. This one will be 45%. Because I have deducted already 5% here. So this area only will be 45%. So it depends on the table which we are going to use. I'll show you the table now which takes from start counting or measuring from the mean, from 0, okay, from mu equals 0. In this case, if we will start from here and I want this point, so I have to count only 45%. I should not consider the 5%, okay, because he will start counting from 0. From 0 up to this point, it is 45%, okay? So I have to be careful. I'll show you now how it looks like in this standard normal distribution table. See? In this table, it's clearly said normal curve from 0 to specified Z value. So to start from 0. Let me delete all this, okay? So it will start from 0. From here. From this 0, okay? So if I want to go right, I have to check how much this area is, okay? So in my case, it is 45%, 0.45. So I'll get now the standard normal distribution table and see how we can find the value of 0.45, because it starts from mu equals 0. So if I want to get this point, I have to get from 0 45% area, okay? The area, the probability is 0.45. So if I look here, I'm looking for the probability. So I should not look at H or Z. I should not look at Z here, okay? I should not look at this Z. Because here this is the Z value. I have to get Z value and find the probability. But in my case, I have already the probability ready because this is the area and the area is the probability, okay? So in this case, I have to find the probability here in these values, okay? So the probability was 0.045, 45%, right? So what is where I can find it here? 0.448, 0.49, okay. So I have here 0.4495 and I have here 0.405. I don't have 0.45 only, exactly. So I have these two values. So I have the option, I can choose one of them. So it will be, in this case, 1.64, okay? 1.64. Or it could be 1.65, okay? There are three schools here. Someone will say, okay, take any one or the nearest one. If both are the same, take whatever you want. And there is another school said, okay, take the average of them. So instead of take 1.64 or 1.65, take the average. So it will be 1.645, okay? Which we are going to use. So we'll take the average of these two. It will be not 1.64 or 1.65. It will be 1.645. Okay, because if you go here 1.6 and up here 1.64 and here 1.65, so 1.64, 1.65, I'll take the average of them, let me write it down, 1.645, okay? So the first step here, I assumed alpha or I get it from my problem. Usually it's given in my problem, it has to be given, but if it's not there, I can assume it's 0.05, sometimes given different values. So if it's not given, I assume 0.05, I assume that 0.05, which is acceptable range, okay? Anything apart from this, it will be rejected. So here I saw that what I have said that mu is less than, this is my null hypothesis, mu is less than mu naught. So my alternative will be the opposite. Mu is greater than mu naught. So if mu is here, so it should be greater than. So if my z, I have two z's now. So one of the z's which I got from the alpha from the table, which will be by memory, you will come to know. If it is 0.5, you'll remember this number. It will be 1.645. Okay, this is my z, and I have another z which will be the calculated z. I have to calculate that using x bar minus mu naught of the sample which I have, divided the sigma or s, divided the square root of the number of the sample, 100 or 30 or 15 or whatever. So I'll get another z. So let us assume that my z became 1.8 or 2.4, for example. Let's assume it became my z 2.4. Okay, so my z became 2.4, so it will be here in the right side. Okay. So mu will be greater than mu naught. Okay, so it means the alternative hypothesis is right, and this is the rejected area for H naught. Okay, so this is the rejected area for H naught, and the value fall within. So 2.4, it will come here. Just write it here. So 2.4 will be here in this area. This is the rejected zone for the null hypothesis. So it falls within the rejected zone of the null hypothesis. So null hypothesis is not valid. It's rejected. Okay. And also at the same time, it is mu is greater than mu naught. Okay. It is greater than mu naught. Okay. So the alternative hypothesis is acceptable. So we reject H naught, the hypothesis which we have for H naught, if Z is greater than or equal to 1.64. So if Z is greater than or equal to 1.4, because this is the rejection area. If it falls here, greater than 1.64, okay, so I have to reject the original one, the null hypothesis, and I have to accept the alternative one. Okay, I hope this one clear. We'll take another example on the other way. on the left side. So in this example, we have taken alpha as 0.1, okay? My null hypothesis will be mu is greater than mu naught, okay? So my alternative will be the opposite one. My alternative hypothesis will be mu is less than mu naught. Mu is less than mu naught. This means that if mu naught is here, it will be less than. So it will be to the left, okay? So always when I assume the null hypothesis and everything I'm dealing with the alternative, but just this for the assumption in order to arrive to the alternative, the first step only, okay? And then everything we are dealing with the alternative hypothesis, okay? So now we knew where we are going to draw this alpha because our mu is less than mu naught, okay? If this is mu naught, okay, so our mu will be in this side. So we are going to draw alpha, the rejection area, in this side. So this will be our alpha, the rejection area. Okay, so if Z falls here, so the null hypothesis will be rejected. Before starting anything in the problem, I have from the Z standard distribution table find what is the Z value corresponding to this alpha. So which table I have to use? I have to use the table which will show like this, left side, because this one on the left side. In the normal distribution table, be careful which table you are using. Okay, I'm going to copy it here now. Let me clear this one first. Okay. So this is the table. I'm looking for the area which is, so here it's calculating from the left. If it is to the left, so it start from here, okay? Start from here and going here. So I have 0.10 from here. It is not starting from the middle, like the positive one, which you have seen in the previous example from the middle. It start from here, start from because here is nothing, here is Z only. So it start from the left, okay? It start from the left. So from the left, I have only 10% here. You remember, we have 10%. So here, this is 10%. I take 10% from the left. Okay, so the value which I'm going to look at, the probability of 10%. Here, these are the probability. This is not the probability, this is dead values, okay? These are the probabilities. So my probability is 0.1. I'm going to look here, where is the 0.1? I find here 0.11, 0.9, so it could be in this area, 0.9. Here 0.8, again, so it should be higher, 0.9. Here 11, 0.1, 0.38. Maybe I have another small, yes, I have, this is the smallest one. Okay, this is the most closest number, which will be this one. Okay, let me make it in the red color. This will be the number, 0.1003. So what is this number? It will be minus 1.2, and go up here, 128. So minus 1.28. Okay, so this will be my Z. So as we can see here, this is Z, which is Z equals Z, this Z from the graph, which called Z critical. Okay, equal 1.28. If you can see here, this is my mu, which is equal to 0. Here it is less, minus something, minus, for example, minus 0.5, here minus 0.7. So as far as I go to the left, it will be smaller. The value will be smaller because minus 0.7 is smaller than minus 0.5. And minus 1.28 is smaller than minus 0.5. So if the value falls within this range, it will be rejected for the null hypothesis, okay? So it's up to 1.28 or before 1.8, I can accept the null hypothesis. If it falls here, if Z, which will be calculated now, is less than 1.8, because less than will go this side. There is 0.5 and 0.7 is less than 0.5. 1.8 is less than this. So if it falls here, it will be less than 1.8. So rejected H naught if Z is less than or equal to 1.28. Okay, because this is my criteria, okay, which I have set initially. So I have got this one, which is 1.2 minus 1.28. So if my z, calculated z, became minus 2.4, minus 2.4 is smaller than this. So minus 2.4 will be here. Let me clear this one so we can see where we are now. Okay. So minus 2.4, it will become here. Okay, because this 1.8, it will be here, for example. Okay, in this area. So it will fall within this rejection area, it will be rejected. Because 2.4 is smaller than minus 2.4 is smaller than minus 1.28. Okay? So anything, if z became smaller than 1.8, it means that it became within this area, it will be rejected. I hope this one is clear. So now we understood the basis or the ambiguity which is not there in the slides, which was there in the slides, which make us confused. And now we'll go back to the slides and we'll try to see what is there in order to address all the points. No need to take more examples because we have already another video for the examples. So now welcome back to our slide again. So here we have this is the calculated z, which will be calculated here, okay? And we have the assumption. So the first we choose the significance level alpha, which might be given in the problem, or we have to assume 0.05 if it is not given. And from here we can calculate z. We can calculate z critical. Okay. Then state what is the null and what is the alternative hypothesis, H naught and H alternative. Then we'll calculate z from here. Okay. And we'll find the value of z from the standard distribution, which is related to the alpha, okay, z critical, and then we'll compare the two results, the calculated with the critical, and we'll write the conclusion. This is as simple as that. I hope this one is clarifying the point.